Good morning, good afternoon, good evening. As people see me. Please, do you have your notebooks? We're going to take a lot of notes, okay? Today, because the machine was broken, please, before going on with acids and bases, because the next thing is balancing equations of acids and bases, you have to know how to balance an equation, and today the only thing we're going to do is balance equations, okay? I think we did it before, and I think you need just one example. I think you need. I'm going to do one example, then I'm going to give you 5 to see if you understand with just one example. If not, we do it again. That is easy, okay? Ay, mío. Okay. This is a chemical reaction. From the arrow to the left, these are the reactants. And here you have the products, okay? Gonna give you an example, and everybody's gonna understand here. If you got, how do you say this? Ginebra, gin, and you got, how do you say tonic water? Tonic water. In Spain, the most famous gin is Larios. There in Malaga, in my hometown, it's made. Here, which is the more famous gin? Gin. Ginebra. Do you know Ginebra? I'm talking about alcoholic beverage here in class. So if you take Ginebra and tonic water, you get a gin tonic. Okay? Or maybe ice. These are the reactants. This is the product. Okay? That's not a chemical reaction, but for you to understand that when you mix things, you get another thing. In a chemical reaction, you mix this methane and oxygen, and you get CO2 and water. Okay? Yeah? Carbon dioxide. It's okay? That's okay? No? What's not okay? What's the confusion? The blue lines, okay. The blue lines are step by step. You get methane and oxygen, you mix them, and you get CO2 and water. Okay? That's the thing. But here you have what?
When you're going to put the numbers in front of the letters, do you multiply it by the small number or do you add it?
You multiply. You add this with this. No, you cannot add because it's not the same, but you multiply this number. But let me wait a little. So here you have one carbon, it's okay. One carbon is okay. But here you have 2 oxygens, and how many oxygens do you have here? It's 3. And how many hydrogens do you have here? And here? That's not possible. In the universe, you cannot get something out of nothing, and things doesn't disappear like this. Here, you have here 4 hydrogen atoms. Here you have to have 4, okay? So, putting the numbers here for having the same number of atoms here and here is balancing the equation, okay? How do you do it? There's an arithmetic form that I'm not going to show you because maybe people get a little confused. But you can try this way, okay? These reactions, this is a combustion. You begin with the carbon, then you go for the hydrogen, and then you go for the oxygen. Okay? If you repeat this, Spanish people, if you repeat this, what do you get? And? Yeah, okay. I'm not gonna say what that means, but if you read this, you get a bad word. Okay? Or a good word, it depends. Grandmas say to the little girls, "Ay, mi chocho." How many carbons here? One. And here you got one. It's okay. How many hydrogens here? 4. And here 4. 2 is not okay. And oxygens, here you have 2. And here you have 3. 3. 2 plus 1. 3. No number is a 1. Okay? So you begin with the carbon. Is carbon okay? It's okay. You don't do anything. Hydrogen is not okay. What do you do? 2 times, I don't know what, must be 4. So which number goes here? 2. So when you change this, you have to recount the number of oxygens. How many oxygens do you have now? How many oxygens? Here, here, and here? No. 2. 2 plus 2 times 1 is 4. So you get 4 oxygens. So which number do you have to write here to have 4 oxygens? 2 times I don't know what must be 4. How many oxygens? Now it's done. Now I'm going to write you 3 more and you do it. Okay? You try. This is always the same order. Carbon, hydrogen, oxygen. And the most tricky thing maybe is to count the number of oxygens here to get how many do you have here. And there's a little thing with a fraction. We're going to see it. Okay?